Well, now we're doing worksheet 3C, and the first question is give the meaning of accuracy and give an example in which a number is accurate but not very precise. Well, look, on page 167 you'll see the definition of precise and precision and accuracy. And accuracy means how close you are to the true value. And whereas precision means how many decimal places were carried out in the measurement. The measurement may be way off, but if there's more decimal places, then it's more precise. For example, 1.11 is more precise than 1.1. So now let's do number 2. Give the meaning of a systematic error and give an example of a systematic error. Well, you can find this on page 163. Now on page 165 it talks about error and how to compute absolute error and percent error. And that's page 165, and that's measured. Absolute is measured value minus true value, which equals the absolute change. Whereas measured value divided by minus true value, all that difference divided by true value times 100% is the percent change. So for number 3, the absolute we talking error? Error is minus 3 years. Whereas the percent change, and this should be a negative 8.8%. Negative 8.8%. So for number 4, 2 students measure the width of a swimming pool whose actual width is 18.5 meters. Bobby reported the width as 18.724 meters, while Carolyn reported the width as 18.6 meters. Which student reported the width more accurately? Well, Carolyn was more accurate. Bobby was more precise because Bobby had more decimal places in his answer. So for number 5, we had to write this given number to the nearest thousandths. Now keep in mind, this is the unit position, the first position to the left of the decimal. Going right, this is the tenth, hundredth, thousandths, 10 thousandths, 100 thousandths. Going to the left, unit, tens, hundreds, thousands, 10 thousandths. So when we round this to the nearest thousandths, we get to the right of the decimal 0.79. 2, the following digit, which is 2, so it rounds down. We round up if the digit to the right is 5 or greater. Now rounding to the nearest tenth, we get 65,152.1. Rounding to the nearest 10, we get 65,150, and rounding to the nearest 100, because the digit to the right of the 1 is a 5, we're going to round up and we get 65,200. Now, significant digits can be found on page 161. And this has 5 significant digits, and here's why. This 0 is significant because it's not necessary to locate the decimal. Then why is it there? Why didn't they just stop at 9? Because it's significant. That's why. Let me give you an example of 0 that's not significant, that is only in place to locate the decimal. This is one significant digit. The only purpose for that 0 is to locate the decimal. Correspondingly, This is one significant digit. The only reason for that zero is these zeros is to locate the decimal. On the other hand, 101, that's 3 significant digits. Interior zeros are significant. Okay, finally, number 7, we have to round the given value to rewrite it in scientific notation showing 4 significant digits. And here it is. And keep in mind, we don't need those zeros to communicate 7.8 times 10 to the 7th. So why are they there? Because they're significant. That's why.